Hello everyone! Today we're going to talk about wireless access point. So what is access point? When you start studying about wireless connectivity, comes to your screen a bunch of different acronyms, a bunch of different meanings. I will start with WAP. What is wireless access point? What is it used for? So today I will explain a little bit about the history behind wireless connectivity, when it always started, and also where we are going to nowadays, the standards that are used so far, and the ones that are going to be released very soon. I will explain to you on this video, so stay with me until the end of this and you will understand a little bit better. Thank you. Okay, let's get started. So what is wireless access point? When you start your journey on studying wireless connectivity, one of the most common acronyms that you may be popping up, WAP, is the very first word that comes to your mind and that it comes to your screen. Because actually, wireless access point is the router Wi-Fi. It's a basically networking device that provides wireless connectivity to whatever it is intended for. So let's give it an example. When you have your wireless access point in your house, you have to basically not running wired, right? Hardwired cabling spread out in your house. You put there a wireless access point and you will have wireless connectivity wherever you are in your house. Sometimes you don't, right? Because sometimes we have some problems about power, about interference, about attenuation, which we are going to talk about in upcoming videos. But the main thing here is that wireless access point is a networking device that provides you wireless connectivity. So with your laptop, your cell phone, tablet, video games, smart TVs, wireless access point is for that, right? It is intended to be used for providing wireless connectivity instead of you getting your wired and putting wired everywhere you need. And from that wireless access point, it will actually provide wireless connectivity to your apartment, house, and that's basically it. This is another common and usual wireless access point that you may have in your home. So before moving ahead with the next upcoming slides, why we need Wi-Fi nowadays? Without wireless connectivity, you won't be able to connect when you are in the office, when you are at your home. Why? Because simply there are some new laptops or even your smartphone don't have wired cable, right? They don't have any RJ45 connector, so you can put your wire there. Wireless connectivity is becoming more and more popular, and that's why some of those devices don't even have wire connectivity anymore. So that's why wireless connectivity comes in and it's becoming more and more popular. So here we have a very, very good example on how the office becomes much more clean and well designed when you don't have cabling. And where is the WAP over here? I will just highlight here so you will see. This is a very simple example, right? I am not saying here that this only access point will be enough for providing wireless connectivity for everybody here in this room. But the point here is to understand that when you have a wireless access point, it may radiate the signal to the users in a very way where you don't even have to have wired anymore. Wired connectivity is becoming less and less popular, and in the opposite direction, wireless connectivity is becoming more and more popular. That's what I wanted to show here. It's also a point where you can also think that you don't need wired cabling designs, wired cabling vendors to run your cabling in your office, in your house, wherever you need to implement wireless connectivity. You should only care about putting the wire in your access point because your access point needs access to the internet or access to the network. And we are going to talk about this in the upcoming videos. So usually the wireless access point is connected to a switch, and it is connected to a switch via cable. Your access point must be connected to the network. Who is behind Wi-Fi standards? So IEEE, or also called Institute of Electrical and Electronic Engineers, is an organization that is responsible for performing standardization for wireless connectivity, telecom, to engineering. And I am not going into much about this organization, but I just put a link here so you guys can go over it and understand a little bit more. And talking about wireless, it always started with this standard over here. Let me show you. Let me highlight here. IEEE 802.11. That is the very first wireless standard that IEEE has launched in a couple of years ago. And it's not a couple. Actually, it's about 25 years ago when IEEE has decided to put all the wireless connectivity standards in a common path where they could make sure that all the evolvements and all the developments on that technology could have a standard. So all the vendors like Cisco, Aruba, HP, Juniper, or whatever the vendor is needs to follow these standards, right? In terms of frequency, in terms of power transmission, in terms of interference, in terms of reserved bands that cannot be used at all because they are only to be used by military. This is just an example. So IEEE is a very important organization that is responsible for standardizing this technology. And Wi-Fi technology is based on IEEE 802.11. That is the very first standard that was to be used in the wireless connectivity standards. Okay, let's talk about the evolution of the Wi-Fi over the past year. It all started, as I just mentioned before, in the 90s, right? In 1997, IEEE is the first 2.4 gigahertz Wi-Fi standard. This standard and its subsequent amendments are the basis for the Wi-Fi wireless networks. So again, it's where it all started. So from there, IEEE started defining the paths, starting studying the differentiations between the types of frequencies and the types of bands that could be used along the upcoming years. So 1997 is the very first year where 2.4 gigahertz band was very first launched. So in 1999, IEEE 802.11b has been launched at this point, or Wi-Fi 1 at 2.4 gigahertz. That is the band that was to be used to reduce interference from microwave ovens, cordless phones, baby monitors, and other sources, right? That also operate in the 2.4 gigahertz band. This is also important to understand. But we are going to talk about this matter, about interference, about power transmission, about everything more in a more detailed way in the upcoming videos. Still on 1999, Wi-Fi 2 was launched, and IEEE 802.11a, or Wi-Fi 2, was the first standard to feature a multi-carrier modulation scheme to support high data rates, right? When we started in the Wi-Fi 1, the data rate to be used was 11 megabits per second. And right now, we could also reach some higher speeds than that. And it also supported 5 gigahertz operation. And of course, the bandwidth, the channel bandwidth that was launched at that time, it was 20 megahertz. Okay? So moving forward, in 2003, 802.11g, or Wi-Fi 3, was allowed for faster data rates. As I mentioned, in the very first one, 11 megabits per second was the higher data rate to be used. And at this point, 54 megabits per second was to be used at this point, right? In the same frequency 2.4 frequency band as 11B, thanks to the OFDM modulation, multi-carrier modulation scheme, and other enhancements. Of course, that I put there the link so you guys can go and check more details in every year, in every step the Wi-Fi passed through the history. 2009, it was when IEEE 802.11n, or also Wi-Fi 4, supported 2.4 and 5 gigahertz frequency bands with up to 600 megabits per second data rates. Right? The high data throughputs enable the use of WLAN networks in place of wired networks. So, of course, it started here, but the path, the journey from moving from the wired connectivity, right, from the cabling connectivity to the wireless has begun in 1999, of course. But at this point, in 2009, we could reach out to 600 megs, right? So at this point, we are talking about almost a gigabit per second. So we are starting to see that at this point, the companies, the industries, and Soho, like small office, home offices, we're starting to think like, okay, I can replace my wired connectivity, my cables with a wireless access point. Okay, that matters to me. That is interesting, right? So it always started here. In 2013, 11AC or 802.11ac or Wi-Fi 5 was the first standard to enable the use of multiple input, multiple output, or also called MIMO, right? Where you have multiple antennas to input and multiple antennas to the output transmission. So you could leverage your existing Wi-Fi infrastructure in the routers, but you could also aggregate more data rates to it. In 2021, we had the new 802.11ax or Wi-Fi 6, and it supports data rates at 9.6 gigabits per second. It improves aggregate throughput and supports and the pervasive use of Wi-Fi in data-heavy and new applications such as video and cloud access. And of course, I'm reading all of this to you because this is also in the IEEE organization site, right? That's why I put the URL so you guys can check this out later and understand better about each step that we had just checked on this history, on this evolution, right? So you guys could see that we got from a point where the data rate was 11 megabits per second, and right now you're talking about almost 10 gigs. 10 gigabits per second. Of course, this is considering that we don't have interference, that we are using the bigger channel widths, like for example 160 megabits, 160 megahertz, right? We are not talking about 20 megahertz as before. And of course, if you start using bigger channel widths, of course, you're gonna see you may be able to face some more interference, but we are not going to talk about this in this very video, right? We are just talking about the evolution of Wi-Fi, what is an access point, what is a wireless access point, what is to be used for, and what is the intention of wireless when we are talking about connectivity in the enterprise, in the offices, in the industry, whatever we are talking about wireless. That's where it all started in 1997, and we are now talking about Wi-Fi 6. And of course, there is Wi-Fi 7 already, but we are not going to describe this right now. We are going to deal with it in a different video, in the upcoming video. Thank you. That's it, guys. Today we're talking about what is WAP, what is wireless access point, where and when it all started, where you can also start studying, gathering some information, why is Wi-Fi so important in our lives, and the most important thing. So we need to understand what is wireless access point, because in the upcoming videos we are going to start talking about the main differences between what is wireless access point running as a standalone mode, flex connect mode, local mode, bridge, repeaters, all the wireless access point modes that you can have in your office, in your industry, and whatever you implement Wi-Fi, you may need to know and you may need to understand what are the different types of wireless access point you may have to implement. You will be implementing in your network. So thanks for the video. Thanks for staying until the end. Please like the video, subscribe my channel, and keep in touch. And thank you so much for your support.